Good morning to all. So I'm Madhava, Chief Engineer and Nodal Officer retired and advisor to the Government of Karnataka. First of all, thank and also for giving an opportunity to present about the multiple benefits, including flood control, irrigation, drinking water, and hydrology, the hydropower. So this is the major dam in Karnataka, Krishnarasagar Dam. So this is the view showing the discharge of water through the floodgates, one of the aerial view of our dam. This is another view of the dam where you can see Brahma Gardens, where the waterfront can attract a lot of tourists. So this is the best example in the entire nation. This is another view of our Krishnarasagar Dam. Next. So this is the Kaveri Basin in Karnataka, catchment around 34,273 square kilometers. And there are two dams in the upstream, Goro Reservoir and also Varangi Reservoir. So both will lead to this KRS dam. So this is sub-basins of Kaveri Basin. Mainly the catchment consists of Yamavati River and also the Upper Kaveri and Lakshmana Tirtha. These are the three sub-basins which contribute water to this KRS dam. So this introduction about the KRS dam. This is a multi-purpose dam constructed across River Kaveri. So this was the biggest contemporary dam in Asia and the second biggest in the world after the Aswan Dam in Egypt. This is designed and conceptualized by Saram Vishweshwaraya, known for his foresight and the grand vision that conceived this project. Started in 1911 and completed in 32. And this dam constructed, only using the labor and less machineries with local materials. The speciality of this is a gravity dam, stone masonry with the lime zone of water act as a binder. And the dam is amongst the first in the world to use automatic gates and represent the marvel of civil engineering of pre-independent India. And the existence of ornamental terrace garden called Vrindavan Garden make it popular picnic spot and also tourist spot. This also supplies steady water supply the water to this Shivan Samudra Shimsha power station. This is about the silent futures, technical silent futures of the KRS Sagar Dam. So already explained, it is started in 1911 and completed in 31. Impounding was started in 1931. The catchment is around 10,600 square kilometers. And the mean annual precipitation was 160.96 centimeters. Annual yield at the dam site is 180 TMC. The length of the dam is around 2.62 kilometers and height is around 30.8 feet. All other these things I'm not going to explain. The contemplated etiquette is around 1,95,000 acres of land. And these are all the maximum design flood discharge and highlighting only few technical details. Yeah, so there are a number of gates, 152 in the south bank and 3 numbers of north bank and 8 numbers of these scouting sluices. Coming to the multiple benefits of KRS, how this KRS dam has transformed the area in Karnataka into this prosperous state. The first and foremost is the dam was designed to irrigate contemplated etiquette around 1,95,000 acres. And also in the downstream, there are some the barrages. From there also, we are again irrigating around 85,000 acres. This is the major benefit because this is a rain-fed area, so there is no other perennial river except this. After this, the whole the area, the desert-like area, now transformed into this the irrigation. Another multi-purpose of this dam is generation of hydropower. Almost 168 megawatt power is generated using this KRS. The third one is flood control, drinking water and tourism. I'll go for a separate slides. This flood warning system is in the catchment and flood warning system in the dam. So the two way we've adapted this. The flood forecasting is being done by observing the rise in the water level of the river with respect to a gauge post established at the river of the upstream side of the reservoir. By observing the reservoir level hourly, the flood is calculated accordingly. The gates are operated. This is a real-time warning system we have installed in the dam, and strictly we are following this from the last 100 years. So again, the Central Water Commission and GeoWiki established the office at the upstream for assisting flood warning in the Kaveri River basin based on the rainfall in the catchment and flow in the river and tributaries. Flood forecasting is done effectively by hourly based on data exchange during heavy floods through the upstream dams like Orangi and Yamauti. Depending upon the inflow forecasting details, we reduce the dam water level and create enough cushion to handle probable water inflow matching with our present maximum discharge capacity. This is very effectively and managing from last 100 years. Coming to the another, the multi-purpose use of this dam, drinking water. So especially Bangalore city, so after 1960, so 5 decades back, we started supplying water to the drinking water to the population of 14.5 million people. Whatever today Bangalore is in the world map as an icon, the Silicon City, it is just because of this the KRS dam, I can see, because so much of our GDP growth is attributable from Bangalore and Karnataka is solely because of the KRS dam. So this is the present population is around 14.5 million people. We are supplying drinking water at the rate of 110 liters per person per day. The core area is around 245 square kilometers. And there is a dedicated department to take care of this. So as of now, so we are supplying around 550 MLD, that is 1,450 MLD of water to the Bangalore city. So this is the BWS is supplying close to 100 liters per person per day. This is the rate of water supply today. This is the Bangalore map. This is the core area of the map. Now the surrounding area, see the development. We are also supplying 110 villages in and around Bangalore, making a mega Bangalore, and we are supplying this 14.5 population. So this is a schematic diagram. So in the downstream of KRS, we are drawing this water to the Bangalore city through the pipeline, series of pipelines. There are 6 phases we have already taken up. In addition to that, there are 2 more districts coming on the way. So Mysore district, which covers around 3 million population. Mandya district is around 2 million population. And also part of Ramnagar, these are all comes under the downstream of KRS. We are supplying all the villages, all the town municipalities, and also district headquarters, the drinking water. So coming to this dam rehabilitation improvement project in Karnataka, DRIP 1 and DRIP 2 with the World Bank assistance, we have taken up. And the first time in Karnataka, we have taken up the rehabilitation of the major 22 dams, especially major iconic national importance dams under the DRIP 1 and also DRIP 2. So DRIP 2, we have proposed around 58 dams for 1,500 crores. And coming to this DRIP 1, we have successfully rehabilitated major dams, especially KRS, Almaty, Narayanpur, Bhadra, and Idkal Dam. Major rehabilitation includes upstream pointing, dam body grouting, replacement of gates, spillway repair. So everything comprehensively, we have taken up all structural measures in Karnataka, and we are able to strengthen the dams, and also we are successful in arresting the seepage. Coming to these non-structural measures like emergency action plan, the preparation of dam break analysis, inundation map, and also the emergency action plan, conducting stakeholder meetings. And these are all updated to the international standards. And also we have used international best practices for our dam through this World Bank project. So with this, I think this is one of the beautiful view of our KRS Dam. So under the downstream of the KRS Dam, Brindavan Gardens, which can attract almost 25,000 maximum tourists per day. And also we are getting a lot of revenue. I think with this, I will conclude my brief introduction about the KRS Dam. So about the multiple uses and other things. Thank you.
Have rainfall gauges in the catchment, and do they feed data automatically? They do?
Yeah.
Okay. And secondly, please explain what you mean by data body grouting.
Yeah, that grouting we have carried out effectively, dam body grouting. And also this the underwater pointing also we have carried out the first time in our dam. Because below MDDL, we have carried out this underwater pointing, and above MDDL, we have carried out the upstream pointing with a specialized material.
So, Madhava sir, somebody is asking, what is meant by grouting? How do you do it? What is meant by grouting?
I'm not hearing properly.
So, he's asking what is meant by grouting and how it is.
Yeah, grouting?
Yes.
Yeah. So this is to arrest the seepage, what we have done. So we have drilled the holes from the top of the dam up to the foundation, and with a pressure we have applied this the specialized material through this grouting, what is called as grouting. And thereby we have arrested all the voids, whatever is there in the body of the dam. So thereby we have arrested the seepage. That's one. So we have carried out the primary grouting, primary host grouting, and we have tested for the permeability test. And again, we have gone for the secondary grouting, and also we gone for the tertiary grouting. This is what the as per the code, Indian the code standard code we have followed, and we have successfully arrested the seepage.
Okay, and finally, there's one last question. Did you make tomography prior to grouting to locate void spaces? How did you identify the void spaces that you needed to grout?
How do you identify the?
Yeah, we have also carried out the tomography, and also we have conducted a test borehole, and also we have conducted this the underwater videography. All the three we have carried out. Below MTDL, we have carried out the underwater videography, so using the specialized equipment, and also we conducted the entire dam. We have conducted a tomography. By tomography, you will come to know what exactly the wet the spaces are there. So depending on this, we have quantified the grouting material, and accordingly we have done this grouting.
Excellent. Thank you so much.